For problem number 5, you have a box has a base whose length is twice its width. So base whose length is twice its width. So I'm going to draw a box, and I'm going to label the width, and then the length is twice the width, but we don't know what the height is. But we do know that the volume is 7,000 cubic inches. And again, the volume of a prism, like you see here, is the area of the base, so that's 2w squared, plus the area, plus the, not plus, the volume of the box is the area of the base times the height. And so we have 2w squared h has to equal 7,000. So those are our constraints. That's our relate step where we relate the two variables together. And a function for the surface area of the box. Well, we know we have 6 surfaces. We have a top and a bottom. So top and bottom would be the w times 2w, so 2w squared for each of those. And then again, we have 4 other surfaces, and those are the sides. So the sides are all, well, actually we have 2 sides that are like the front and back here, WH. So we have a WH there and a WH there. And then we have 2 sides that are 2W times H. So the side and the side, left and right. So we have 2WH and 2WH. So the surface area in terms of all this stuff would be 4W squared. And then we have 1, 2, 3, 4, 5, 6. So we have 6 WHs. I just took these 4, so these are all like terms, if you think about it like that. 2 plus 2 plus 1 plus 1, that's 6. So we have 6 WH. But again, we use our constraints over here. H would be, if we divide both sides by 2W squared, then we're going to get 2 goes into 7,000 3,500 times. And then we have 3,500 divided by W squared. So our surface area in terms of W is 4W squared plus 6W times 3,500 over W squared. And so we get 4W squared plus W's are going to cancel. 6 times 3,000, that's 18,000. 6 times 500 is 3,000, so that's 21,000. So we have 21,000 over W, and that's our surface area in terms of W. So we have that, but we're still trying to figure out what are the dimensions of the box that minimizes the surface area. I think that should be minimize. What are the dimensions? What are the ones that minimize the surface area? So we just have to type this into our calculator and see what we get. So let's move that over and go to y equals. We have 4w squared, so we'll use x as w, plus 21,000 divided by w. And then, so let's think about some constraints here. The volume of the box is 7,000, but our window, most likely, our x min has to be 0. And our x max, not sure, but I'm going to try 50. That's probably a little much, but maybe not. And then I'm not sure about the y max. Let's see if we get lucky. Not at all. Okay. So this is where I'd hit the trace button. And I look at the x, and I'm seeing my y. I'm trying to minimize surface area, so I'm seeing my area go up. But if I go back, I can see the surface area is going down. I'm looking at the y values here, and I'm noticing the y value is pretty high. Okay, so when x is really small, y is up at 18,000, but as x moves to the right, y drops down to under 2,000 maybe? So right around 2,000. So I need my y max to be above 2,000 for sure. And let's try, that's where it gets the lowest, but I was up at about 18,000. So let's try that. Make sure that x-res is 3, and there we see a better picture of the function. And again, we're trying to minimize the surface area. So minimizing the surface area, second calculate minimum, and then I move the cursor to the left, then I move the cursor to the right, get back here somewhere near where the minimum is, and we want the dimensions. So remember, the x on our calculator is the w on our figure, and so the x is 13.795. So if w is, let's see, where can I put this here? W is 13.795. That means that the width 2w equals, oh, and by the way, let me show you this. This is kind of cool. If you go to second quit, that x value that you just calculated, it's actually stored in as your x. So if you hit x, enter, it has that value right there, and we want to store that STO with an arrow right next to the 1, alpha A. So that's my value. Now I can multiply that by 2, so I get my width of the base. That's 27.589. So 27.589, and then the height. Remember the height? That's 3,500 over w squared. So we take 3,500 and divide that by our alpha A squared, and I get the height of the box, and the height of the box is right there. So we have 18.393. And was that feet? Inches. So inches, inches, inches. And that is how we do it. Length, width, height.